Hello, welcome again. Now we are going to see one more derivative or one more analogs from the anti-metabolites, that is pyrimidine derivatives used in treatment of cancer. The pyrimidine derivatives here, most of them are uracil derivative and cytosine derivatives. There is no thiamine derivatives, especially they are not effective in cancer treatment. So mostly uracil derivative, prominent one in the therapy, uracil derivatives and cytosine derivatives. Among the uracil derivatives, 5-uracil is very, very prominent. You can see the structural similarities. Listen, you need to see the first video before starting to learn about this. So let us see. So pyrimidine derivatives, here examples of drugs are these. In methotrexate, proltrexate are the examples of folic acid. Leucovirin or folinic acid is the antidote. Now here, what is that? 5-fluorouracil, floxyuridine, trifluorouridine, three fluorine molecules are present. Floxyuridine, you see there is no sugar molecule. There is sugar molecule here. There is no sugar molecule in 5-fluorouracil. Otherwise, same to same. Uridine nucleus, ribose sugar is present. Uracil plus ribose sugar, then it is called as uridine. As it contains fluorine, we are calling it as floxyuridine. Floxyuridine. Now, this is new drug, capecitabine. Capecitabine, very good drug. It is available in the form of tablet. Tablet, very, very good, effective drug. Here also, uracil derivative is present. You can see it. Timed cytosine like it is present, but in the body, what happens is that it converts to uracils, 5-fluorouracil. That's why we classified here. What's the drug? Capecitabine. Capecitabine. These are the 4 drugs which we classify under pyrimidine nucleus. Pyrimidine antagonist. Under that, uracil derivatives. That's what they are, uracil derivatives. Now, this 5-fluorouracil is it is blocking thymidylate synthase. I told you in previous video that methotrexate also blocks thymidylate synthase indirectly because there is no formation of N5-N10 methylene FH4. When there is no N5-N10 methylene FH4, it cannot react with deoxyuridine monophosphate. So methotrexate indirect, but whereas uracil and all these drugs, they block thymidylate synthase directly. And especially uracil is a suicidal inhibitor. During the process, just like terrorists, they blow. Even these drugs, this drug, 5-fluorouracil, will be destroyed itself. All these drugs in the body, they're converted to 5-fluorouracils. All these drugs are prodrugs. They're getting in the body sugar, phosphate molecule, then they block activity. So they're prodrugs. They're also prodrugs. Prodrugs. So what are that? Let us see. First, as we learned, examples of drug, We learned that it is thymidylate synthase blocker. Thymidylate synthase blocker. You can see with the help of this uh, diagram from the Graham Patrick textbook. This is very good diagrammatic representation. So please carefully listen. Now, one important thing you need to observe is that when X, here you see, this is a, what is that, uracil derivative. When X is H, here we given X, if X is H, it is uracil. If X is fluorine, it is 5-fluorouracil. 5-fluorouracil. Now, for the understanding of mechanism, this is N5N10 methylene FH4, which we got from FH4. FH4. See, FH4 is converted to N5N10 methylene FH4. Now, this during the synthesis of deoxythymidine monophosphate, this is the end product. And this is also end product which is recirculated in our body. Now, three components are very important here. One is the enzyme. What is that enzyme? Thymidylate synthase is the enzyme. Thymidylate synthase is the enzyme. It is uracil. Now we are considering X as HN. And one more is N5N10 methylene FH4. Methylene means this, and this is between 5th position. This is 5th. So you can get numbering again. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10th. So between 5th and 10th nitrogen, there is methylene group. That's why it is called as N5N10 methylene group, FH4. AR means that is PABA glutamic acid is associated. We just made it as AR in order to fit into our slide, Now, let me clear all this. I hope you understood. All these three, what happens is the enzyme. What is the enzyme? Thymidylate synthase. Enzyme is nothing but amino acids. Amino acid, there must be one amino acid having cysteine or methionine. The sulfur containing amino acid. Sulfur has lone pair of electrons that will bind to this carbon, 6th carbon. 6th carbon. Now, when it binds, what happens? The pi bond, which is between 6th and 5th, will shift between this carbon and this methylene carbon. There is a pi bond. Now, pi bond is converted to sigma bond. You can see in this diagram. What happened? Sulfur will attack this carbon, and now this pi bond is converted to sigma bond that is attached between 5th carbon and methylene carbon. That's what we are seeing. That this is a 5th carbon and methylene carbon. Now, as I told, first we are studying normal process. As X is H, the normal. Now what happens now? In the body, H is taken away easily. Proton, it goes out as proton because water is present, water abstracts this proton. When it abstracts, no, what happens is that now the bond between 5th carbon and hydrogen will become a pi bond. is becoming a pi bond. You see here, pi bond. When it becomes pi bond, what happens is that now the enzyme is getting dissociated. Enzyme is getting dissociated. And this, see, this structure you are getting. Where now here again, the released proton, which is abstracted by water, will come and attack onto the nitrogen, and there is breakage here. When it breaks, this molecule will become deoxythymidine monophosphate. And this is called as FH2. You can see it, FH2. FH2. This is how it is occurring. Now consider that. Now X is fluorine atom. Let me take different color. Now X is fluorine atom. X is fluorine atom present. As you know the process how it occurs, enzyme is attaching here, fluorine. This is it. Now when there is fluorine here, what happens? No, the fluorine cannot be released. Fluorine is a bad leaving group, whereas proton H plus is a good leaving, L-E-A-V-I-N-G. Good leaving group. Which one? Proton. Whereas fluorine is a poor leaving group. Now, what happens is that when there is a fluorine, as it cannot be abstracted by water, it stays here. So when X is F, the reaction mechanism is halted. So that's why, as you see, just like terrorist, it is killing itself. That's why this drug is called as suicidal enzyme inhibitor. As the reaction is halting here, there is no formation of deoxythymidine monophosphate, which is further converted to DNA, RNA. So 5-fluorouracil is very, very good drug in this condition. So this is the mechanism of reaction. Now let us see what are its uses. Where it has multiple uses, especially used in treatment of skin cancers. Solar keratosis, actinic 1, what is that? Basal cell carcinoma. In that conditions, it is very, very good drug. It's also available in the form of injection, especially for this skin. It's also available in the form of creams. Apart from this skin cancer, it is also used in colorectal cancer, esophageal cancer, stomach cancer, pancreatic cancer, breast cancer, cervical cancer. So these are the uses of this drug. Next one, let us see capecitabine. Capecitabine is also one more drug, which is excellent drug. Nowadays, the side effects whatever we are seeing from 5-fluorouracil are minimized by capecitabine, and beauty is that it is given in the form of tablet. It is given in the form of tablet form. Now, this is also used in treatment of breast cancer, GIT, colorectal cancer. Very, very good conditions it is used in. Colon cancer, it is very, very good. The drug is prodrug of 5-fluorouracil. The side effects, whatever we are seeing with 5-fluorouracils, are less with this capecitabine. The trade name for this is Xeludo. One more advantage, it is given in the form of tablet. Now, in the body, what happens, you see, there is a this group, carbamate group is present. Carbamate group is present. This is uracil derivative. Now, our pyrimidine derivative. Let me tell pyrimidine nucleus. Now, what happens is that by it has, see, it is attaching by pentyl carbamate or urethane. Pentyl urethane group or pentyl carbamate group, which is present extra. Now, in the body, by carboxyesterase in the liver, there is breakage here between nitrogen and carbonyl group, resulting in, see, already there is no hydroxyl group. Usually at the hydroxyl group, at the fifth carbon, there should be CH2OH on the sugar molecule. There is no hydroxyl group. When it is a pentyl carbamate group attached, it is called as capecitabine or CAP. The abbreviation for capecitabine is CAP. Now, because of carboxyesterases, you are getting, you see, 5-deoxy, 5-deoxy, 5-fluorocytidine, 5-fluorocytidine. Now, by the help of deamination process, so these are the red lines where it is cleaving. By deamination process, we are getting so 5-deoxy, 5-deoxy fluorouridine. Now, by uridine or thymidine phosphorylase, what happens? You are getting 5-fluorouracil. Now, this is the 5-fluorouracil, which is acting similar to that what we studied in previous slide. It is blocking thymidylate synthase process suicidally. What is advantage of this drug? It is given in the form of tablet, and slowly the drug is converted to 5-fluorouracil. So there is no much toxicity. So less stomatitis and less neutropenia. The side effects with the capecitabine, yeah, is less than 5-fluorouracil. 5-fluorouracil. Now you can see one more drug, cytarabine derivative, cytosine derivatives. Now you can see it here. What is that? One of the example of drug is cytarabine. Cytarabine. So this is a drug. Now this is the natural metabolite. You can see it. This is natural metabolite, which is present in our body, which is a component of DNA, and this binds to guanine. Guanine. Now this is cytidine. That's what we are told. Cytosine attached to ribose sugar. Now, if there is no hydroxyl group here, if there is no hydroxyl group, then it is DNA component. Now, cytidine is having ribose sugar. You should listen carefully here, please. It has ribose sugar. Ribose sugar. In the molecule of cytarabine, the name itself, you see, the hydroxyl group, which is in alpha configuration, it has changed to beta configuration. Then this sugar is called as arabinose. What is the sugar? Arabinose. Here it is ribose sugar. Ribose sugar. Cytarabine has arabinose sugar. So this is the structural difference. Structural difference. So cytarabine is also called as arabinoside. Arabinoside cytosine, because arabinoside like nucleoside, arabinoside, base plus sugar. So arabinoside is the sugar and cytosine is the nucleic acid. If you combine these first three letters and C, it is also called as Ara-C. Ara-C. Now it's also prodrug, as we told. Prodrug. Methotrexate is not prodrug. Please remember, these drugs are prodrugs. So it is a analog of deoxycytidine. See, this is deoxycytidine. Cytoarabine is the first series of cancer drugs that altered sugar component of nucleoside. This is the first drug which was introduced into the market, into clinicals, where they have done some changes on the sugar molecule. Now, let us see how it acts. Sorry. So this drug block DNA polymerase enzyme. It blocks DNA polymerase enzyme. Here you see, new DNA polymerase, so we'll add new nucleotide. So consider this is one strand which is acting as a template, and with the help of the template, you are getting new strand here. Now, the enzyme which is responsible for adding new nucleotide is DNA polymerase. Now, our drug blocks this. How it blocks is that usually the natural nucleotides consist of ribose sugar, deoxyribose sugar, but it has arabinose sugar present in our body. In this drug, it is the cytoarabine consists of arabinose sugar. So cytoarabinose, though it has arabinose, there is phosphate formation. There is no issue here. Now this is activated triphosphate form. Now here it gets incorporated into DNA. But what happens is that there is no sugar molecule attached. There is different sugar molecule. Sorry, there is sugar, but arabinose is present instead of deoxyribose. So what happens is that the DNA polymerase cannot add growing nucleotide. So there is blockage of this action. This is the mechanism of action of this drug. Ara-C or cytoarabinose. So this is arabinose metabolism, cytoarabine. In the body, cytoarabine, you see in the body, what happens is that by deamination, it is again converting into uracil format. So this is metabolism. These drugs are mainly used in leukemia. So cytoarabine or Ara-C is very good drug in the treatment of leukemiasis, acute myeloid leukemia, acute lymphatic leukemia, chronic megalogenous leukemia, and non-Hodgkin's disease. The important is that these drugs produces leukopenia, anemia. These are the side effects. So this is next one is one more new drug, that is gemcitabine. Gemcitabine. Here it is cytosine derivative. What happens is that here you see at the second position, fluorine atoms are presented. 2 fluorine atoms are present. In cytoarabinose, it is arabinose sugar is present. In gemcitabine, it is fluorine particles are present. Gemcitabine. The same way, it is cytosine derivative, and it's also block DNA polymerase enzyme. Polymerase enzyme. Because of these halogens, they're highly blocking this DNA polymerase enzyme. In the body, by the phosphorylation, it gets activated. Gemcitabine is also prodrug. So you can see it is used in treatment of lung cancer, breast cancer, pancreatic cancer, urinary bladder cancer, ovarian cancer. So this is now this is my references. Same references, very good. These are very good books. You get maximum information, whatever I told, the chemistry. Indirectly, we are also studying SAR. Then some of the questions you can see. Carbamate containing drug from the following. Try. Capcitabine. Capcitabine is a drug which we were telling you. See, this is the carbamate containing drug. Carbamate containing drug. Okay, that is capcitabine, carbamate containing drug. This is, you can see the structure. For your convenience sake, I placed here cytosine analog from this is gemcitabine. Even capcitabine is also cytosine derivative. Because you can see capcitabine in this drug. Where is that? This is also cytosine derivative. When there is nitrogen and keto group, then it is a what is that? Cytosine derivative. Now, which of the following drugs does not produce 5-fluorouracil on metabolism? The only drug is all these drugs. Capcitabine, though in the body, it is, though it has cytosine structure, it is converted to 5-fluorouracil. Gemcitabine will not produce. So gemcitabine. So let us see one more time what is gemcitabine. This is fluorine molecule is present. So there is no chance of converting into uracil derivative. Gemcitabine is the one which does not convert here. This is the which of the following drugs in slide number 15. So which of the following drugs does not produce 5-fluorouracil on metabolism is gemcitabine. All these drugs will produce. Capcitabine is cytosine derivative, but still it is converted to 5-fluorouracil. Here, the fluorine molecules are present on sugar portion. Okay, gemcitabine. Next, you can see it. Which of the following drugs used in solar keratosis? That is fluorouracil. I told you this is the given in the form of ointment. If you can remember, so this is an uracil can be given in solar keratosis. This is it. Thank you very much. So this is my lecture for this pyrimidine derivatives. If you have any doubt, please do comment. Thank you.